Okay, let's give you guys some more practice. So here, differentiate this. Find dy by dx of this. You could use a combination of the quotient rule and the product rule here, but I wouldn't recommend it. Well, anyway, find dy by dx of this thing here. Okay, so press pause and have a go. Okay, so visualize this here as one block, one bubble here times another bubble. But visualize this bubble as to the power of -1. So visualize this whole thing here as this here. Okay, so yeah, so hang on. Looking at this here, visualize it as one bubble, and this is another bubble here. But then visualize this bubble as to the power of -1, to the power of -1 here. Okay, and then now take the natural log of both sides. So you're here at the moment. Take the natural log of both sides. That will then give you this. Okay, so here in a way you've got one block, one thing multiplying with another thing. So whenever you have the natural log of A times the natural log of B, then that's the same as natural log of A plus the natural log of B. So that's this thing here, the natural log of this thing here, plus the natural log of the whole thing here. Okay, so here will take you to here, and then use the same. Oh yeah, and then looking at this here, whenever you have log of something to the power of -1, you can move this -1 out here. So this -1, well, you can take it out over here. So this -1 becomes in a way -1 here, but we don't bother putting the -1. We don't bother putting the 1 here. Well, anyway, this thing here, move it out here. That will then give you this. Okay. So now looking at this here. Hang on. Oops. Now looking at this. So you've got looking at this here. You've got the natural log of this whole thing here. But this whole thing here is one thing multiplying with another thing, multiplying with another thing here. So you can use the same process here. So that's the same as saying, so this is like one block here. Well, this block here is exactly the same as this block here. Okay. Well, I've got to rush through this because my battery is dying. So and then blah 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 blah. Oops. Hang on. So we are currently here, and then blah blah blah. Tidy this up. Blah blah blah. Tidy this up. And then blah blah blah, and then, well, I hope you can follow it. I have to rush through this. The battery's running low. So here, the red line represents our original graph. The blue line represents a derivative. Looking at this, you can see, you can double check. So here it says that the gradient here is 0. Looking at the blue line, the derivative does say it's 0. Looking at the red line, it's going uphill, 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 uphill. So looking at the blue line is in the positive, positive, positive. Okay, and then looking at this here is positive, positive, positive. Looking at the blue line, it's still in the positive, positive. And then looking at the red line there, it's going downhill. So looking at the blue line, it's in the negative realm, and so on. So this does indicate that our derivative here is correct. Okay, all right, okay.